Welcome to Short Planetary Geological Essays, narrated by Daniel Hutchinson. The easiest way to appreciate the moderating effect that water and water vapor have on climate is to look at the other planets within our solar system that lack either oceans or an atmosphere. The Moon is about the same distance from the Sun as is the Earth, but obviously, even to the layman, it has no atmosphere and no oceans. Without the moderating effects of oceans and/or an atmosphere, daytime temperatures on the Moon exceed 250 degrees Fahrenheit, and nighttime temperatures sink below in the same amounts within the minus temperatures in degrees Fahrenheit. Observing with a critical thinking mind, the average temperature on Earth is around 61 degrees Fahrenheit. So, it becomes obvious then to be absurdity in the extreme to consistently make unsubstantiated claims that greenhouse gases make the Earth warmer than the Sun alone would make it. To the contrary of all this self-evident absurdity, if the Earth existed without a moderating atmosphere and a ocean, the Sun alone would make the Earth hotter during a 12-hour day and colder during a 12-hour night. In the case of the planet Venus, it is very often cited in the scientific literature and science documentaries as a perfect example of a runaway greenhouse-affected planet, a planet sitting next door to us in our neighborhood of the solar system with a 96% CO2 atmosphere and a mean surface temperature of 864.3 degrees Fahrenheit. The surface of Venus is very much hotter than Earth, not because its atmosphere contains so much CO2, like the scientific literature and documentaries constantly claim, but because its orbital distance compared to Earth's is 30% closer to the Sun, with a planetary-wide atmosphere that is 90 times denser at its surface than Earth's. With Venus having a greater mass of atmosphere translates into having much greater adiabatic compression, where heat is generated through atmospheric compression within a high-density atmosphere, which in turn produces much higher surface temperatures. For an example, here on Earth, temperatures at Death Valley and the Dead Sea are hotter than anywhere else on our planet because of having the lowest elevations than anywhere else on Earth relative to sea level, which all translates into increased adiabatic compression. Logic dictates, then, that it is the direct heat from the Sun that is creating the extremely high temperatures on Venus, which inevitably leads to a high CO2 content in the planet's atmosphere, and not the other way around. Even before Venus possessed a substantial atmosphere early in its history, the planet was evidently too hot to retain any water within a liquid state. Thus, there was not even a slightest of a chance of Venus coming close to having any ocean or oceans forming on its surface. Without oceans existing on any planet in our solar system to absorb CO2 and sequester it into sedimentary type rocks like limestone, which is a type of rock that is only formed within detrital type rock beds of a saline aqueous environment, scientific logic dictates that virtually all of the CO2 on Venus must reside in its atmosphere. By contrast, here on Earth, 70% of our planet is covered by deep oceans. 99% of the carbon on Earth is sequestered via seawater into limestone. Also, Earth's atmosphere contains only 0.04% of CO2, making CO2 literally a rare gas, which therefore has no significant effect on Earth's climate. To sum all this up with the quote of Dr. Frank Schnell, "The absence of any obligatory relationship between CO2 levels and temperature is evident throughout the last 500 million years, known as the Phanerozoic. Therefore, while the scientifically bankrupt concepts of tipping points and man-made runaway greenhouse effects have obvious political applications, the mere existence of the Earth's oceans make all this an impossible and obscene fantasy." Dr. Frank Schnell. Thank you for watching.